In our last class, we completed the chapter polymers. Today we are going to start the second last chapter of organic chemistry, that is biomolecules. Biomolecules are the compounds which are related with the living things, we can say, for the metabolic process and all. Say for example, carbohydrates, protein, fats, vitamins. These are the examples of biomolecules. So first, in this chapter we are going to study about carbohydrates, proteins, then vitamins and nucleic acid. Okay, now, so the first topic that we are going to discuss is carbohydrates. So first we'll go for the definition. Carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones, or the compounds which produce such units on hydrolysis. Okay, so there is a term called optically active polyhydroxyaldehydes or ketones. So optically active, as we have studied in our previous class, that is class 11, we know this term. Optically active means if you passed a plane polarized light through that, it will rotate the plane polarized either to left or to right. Based on that, we have got D and L form, as we know. Now polyhydroxy means there are many OH group, aldehydes or ketones. So we have got the example of carbohydrates. This is the structure for glucose. We very common with this because we'll be frequently coming across this glucose structure. And this is for fructose. Okay, glucose and fructose, they have got the same molecular formula, but they have got the different structures. And the different structure means one has got aldehyde functional group and other we have got ketone functional group. Okay, so they are also called functional isomerism, we can say. Now in glucose we can see they have got 5 OH group. One is primary and 4 others are secondary type of alcohol, and one aldehyde group. So they are called as polyhydroxy aldehydes, and each carbon atom, they are optically active. That means they can rotate the plane polarized light. Okay, this is the D form of glucose. D form means we have to see the second carbon atom from the bottom. If OH is on the right hand side, it is D form. If OH is on the left hand side, then it is L form. So this is D glucose and this is D fructose. Okay, now next we have to see the classification of carbohydrates. Carbohydrates can be classified on the basis of their behavior of hydrolysis. That means when you hydrolyze, on that behavior we can classify it. Say for example, monosaccharide. Monosaccharide means a carbohydrate that cannot be further hydrolyzed. That means if you add water, we don't get any kind of unit. That is called monosaccharide unit. Example is glucose, fructose, ribose. These are the example of monosaccharide. Now over here we have got a table that we need to understand how to name monosaccharide units. Say for example, if you have got the number of carbon atom, say for example 3, the general norm is triose. Tri stands for 3, triose. Okay, if it is aldehyde, we call it as aldotriose, and if it is ketone, then ketotriose. Aldehyde, aldo, ketone, keto. Similarly, if you see for 6 carbon atom, we call it as hexose, and if we have got aldehyde, we call it as aldohexose, and if it is ketone, then we call ketohexose. Now in this, if you see for the above glucose structure, there you'll find that we have got 6 carbon atom and one functional group is aldehyde, so we can also name glucose as aldohexose. Similarly, fructose as ketohexose. The other examples you can just go through it. Next thing, classification we are doing. First was monosaccharide. It can be also classified into the second type is oligosaccharides. Oligosaccharide means when the carbohydrates, when hydrolyzed, we might get 2 to 10 monosaccharide unit. Okay, if the monosaccharide unit you get 2, then we call it as disaccharides. If you get 3, we call trisaccharides, 4 tetrasaccharides. Okay, depending on the number of monosaccharides. Okay, for example, lactose Or sucrose on hydrolysis gives one molecule of glucose and one molecule of fructose. Okay, so this we can call it as disaccharides. If it gives 3 units, then we call trisaccharides, like that. Then we have got polysaccharide units. Polysaccharide unit means carbohydrates which on hydrolysis will give many number of molecules. Will give you many number of molecules. Say for example, starch, cellulose, glycogen. These are the examples of polysaccharides. The next topic that we need to discuss is what do you mean by reducing and non-reducing sugar. Reducing sugar means the saccharides or the carbohydrates which can reduce filling solution and tolerance reagent are referred to as reducing sugar tolerance reagent that gives the tolerance test. Okay, all monosaccharides whether aldose or ketose are reducing sugar. Example of reducing sugar are maltose and lactose. Next is non-reducing sugar. So the saccharides or the carbohydrates which do not reduce filling solution or tolerance reagent are called non-reducing sugar. Okay, so filling solution and tolerance reagent. If they reduce, reducing sugar. If they don't reduce, non-reducing sugar. Example is sucrose and starch.